Hi students, in this video I'll be going through the 2023 O-Level A Math Paper 1 question 3. Alright, so this is a question regarding the proving of trigo identities. Okay, so for proving of trigo identities, we always want to start from the more complicated side. So for this particular question, it's quite obvious that the left-hand side is more complicated. Okay, so that is where we want to start off. Okay, so cosine square theta, then the denominator we have cosecant theta minus 1, cosecant theta plus 1, plus sine square theta over secant theta minus 1, secant theta plus 1. Okay, so usually for this kind of proving of identities question, at each stage, I want to pause and ask myself, what can we possibly do to simplify this expression? Okay, so one of the things that you may consider is you want to replace this cosine square theta, right, using the identity with 1 minus sine square theta. And then you see over here you have a plus sine square theta, right? So you may think you want to combine together and maybe can get rid of the sine square theta. Okay, but if you look at the denominator is not the same. Okay, so if the denominator is not the same, then you also cannot combine them together and get rid of the sine square theta. Okay, so taking this into consideration, I will not want to change cosine square theta into 1 minus sine square theta because that would serve no purpose. Okay, then if you look at the denominator now, it's cosecant theta minus 1, cosecant theta plus 1, secant theta minus 1, secant theta plus 1. So just one look at this, I will be tempted to do this. Okay, A minus B, A plus B is going to become A square minus B square. Okay, so I'll be tempted to use this special product, okay, to simplify the expression to A square minus B square. And indeed, this is possibly the only thing that we can do to proceed to the next step, right? Okay, so let's do that. So cosecant square theta over, okay, so A minus B times A plus B is going to get A square minus B square. So A is cosecant square theta now. Okay, so A square minus B square. B is 1, so 1 square will just give me 1. Okay, so just like this, we can simplify to this, right? Okay, so we'll do likewise for the second term over here. Okay, and we will get secant square theta minus 1. Okay, so over here now we can think of using some identities, okay, especially when we see there's a minus 1 over here. Okay, because there are some identities that we can use. So firstly, cosecant square theta is equals to cotangent square theta plus 1, right? Okay. And then secondly, secant square theta is tangent square theta plus 1. So we can replace these two identities inside. And why do we want to do so? Because we can simplify even further. Because if we introduce a plus 1 here, the plus 1 combined with the minus 1 here, then we'll get rid of the numbers, right? So that's what we're going to do now. So cosecant square theta over, cosine square theta. So cosecant square theta is now cotangent square theta plus 1, right? So cotangent square theta plus 1 and minus 1, okay? So minus 1 is from the original step, okay? Okay, then you have sine square theta over, okay, secant square theta I can replace with tangent square theta plus 1 and minus 1 from the previous step. So like this, you see, we can simplify the expression. So every single step should serve a purpose, okay, to simplify the expression further. Okay, so we end up with tangent square theta, right? So you can see how much we have already simplified the expression from the initial fraction. Okay, then from here, we can simplify further. So one thing to do is that if you want to combine, let's say cosine square, or rather simplify cosine square over cotangent square, you will try to convert cotangent into cosine over sine. Okay, so and that's what we're going to do. So this is going to be cosine square theta over sine square theta. Okay, so cotangent is cosine over sine. Okay, then we'll do likewise for this. Tangent can be written as, okay, tangent square theta is sine square theta over cosine square theta. Okay, so what are we going to get from this? It's a fraction over another fraction, okay? So let's try to simplify this out. Okay, so if you don't know what's going to happen here, how to simplify this, okay, then you can write out more working. So do you agree with me that cosine square theta over cosine square theta uh, divided by sine square theta is actually can be actually written like this, okay? Correct? So this thing is divide, correct now? Okay? So remember, if you want to simplify this, we got to change it to times. So it becomes this over this. Okay, then the cosine will cancel off and you will be left with just sine square theta. Okay, so over here will just become sine square theta. Okay, then if you do likewise for this side, it will just become cosine square theta. And then finally, we'll just apply this third identity that we are going to use today. Sine square theta plus cosine square theta is equals to 1. Okay, so this is something that we are all too familiar with. Okay, so finally, you'll be able to show what you need on the right hand side, right? Okay, so this is how you deal with questions regarding the proving of trigo identity. So at every single step, you ask yourself what can possibly be done to simplify the identity. Okay, and then you perform that step, and then you see from there on how can you move. Okay, of course you need to be familiar with all these identities. Okay, if not, this may not come to mind, this may not come to mind, and then you can't simplify it further. Right? So this is how we solve proving our trigo identity questions. All right.